Alright, so we are doing antiderivatives. Before we get into what antiderivatives are, let me do a quick recap of like generic derivatives, because that's going to help us get to the knowledge that we need. Let's start off with something very, very simple. F of x is equal to x squared. That is your normal function, f of x. If I wanted to find its derivative, if I wanted to find f prime, this is something you have been doing now for quite some time. And there was a rule that I used with it. What was its name? The power rule. Just for reminder's sake, remember that the power rule is d over dx. The derivative of any variable raised to an exponential power, otherwise known as some polynomial function, is I'm going to bring the power down and reduce the power by 1. So if I'm doing that, this is going to become 2 times x. Fairly simple, yes? Yeah. Let's do one other one that is very simple. Let's go f of x is equal to 6x cubed. If I wanted to find its derivative, again, same thing with my power rule. I have the 6 that is down. I bring the 3 down as well, so 6 times 3, x, bring the power, reduce it by 1. So this is equal to 18x squared. Fairly simple, yeah? Alright, this function, this is the function, this is its derivative. If I wanted to go backwards, in this case, say I was given f prime of x, and I wanted to find f of x, what operation would I do? Yeah, I would be doing the integral. I would be finding, yes, the area underneath the curve if I had bounds on this, if I was going from a point to another point. But if I'm just going backwards, I am not finding its derivative, I am finding its... That's what an antiderivative is. It's the function that you started off with. It's working backwards from a function to find out if I took a step backwards, what, when I took the derivative of it, would give this function. It's basically... How would you go from f of x? F of x, I would just say the antiderivative of f of x is this function. Now in our case that won't have any meaning if I'm just looking at a function. You don't need to think that it's like f star or anything. It's nothing crazy. It's just the antiderivative of f of x. That's just what we would call it. Cool? We don't have any notation for it as we're going through that. Now there is the equivalent of the power rule, but working backwards. And this rule, remember when we, or you probably don't, remember when we introduced this like way back a long time ago, and how we sort of looked as like, that's weird, okay, and now how you can look at this and just do these like that, and it's just like second nature to you? We are going to do the same thing, and hopefully this one will become second nature to you as well. Here's the rule. The reverse power rule says if I'm integrating any variable raised to an exponent, don't forget your dx, that's going to be equal to x. And now think about it. If I was going forward, I reduced the power by 1. If I'm going backwards, what do you think I'm going to do? Increase it by 1. And in this case, if I was multiplying by this, what would be the opposite? Dividing. But what you have to be careful of, it's not dividing by n, it's dividing by n plus 1. This is the reverse power rule. It's something that you will need to know like the back of your hand.
Why is it dividing by n?
Let me go through an example, and I think you will see the mechanics of why that is. Because it has to do with like the opposite of what you're trying to do and what you're trying to cancel out. Cool? Alright, let's look at some very simple examples. Example 1. We are doing x squared. Thank you, Leo. Very cool.
You're welcome.
f of x is going to be equal to x squared. That's the function we're going to be dealing with. I want to find the integral of x squared dx. So, using my reverse power rule, it says I'm going to increase the power. So it's going to be x to the what power? 3 divided by what? 3. 3. So I started with 2, increased it to this, increased it to this. Now think about it. You can always check these. If going in reverse was the integral, if I want to go back to my answer, what would I do? Take the derivative. What's the derivative of just x cubed? 3x squared. Divided by 3, what happens? They give away. That's why it's in plus 1. So that when I divide by that number, it gets rid of the number that I worked myself back up into. Cool? Mm-hmm.
I disagree.
Why? Why?
You said n minus 1.
Yes. This is the power rule. This is n minus 1. Going forward, it's n plus 1.
Oh, fuck, I wrote the rule.
Dude! We're recording!
Oh my god, I said fart.
Uh-huh.
Recording?
Yes.
Autocorrect for fart.
Allison! Shh.
Whenever you take the derivative of it, how come you didn't take the derivative of
Because it's a constant. Remember, this is really... And I will typically rewrite these just because there's no rhyme or reason to this. I just like having a coefficient, bless you, up in front. This is 1/3 x cubed. Right? Dividing by 3. You don't do the quotient rule when it's a function divided by a number. You only do it when it's a function over a function. This is 1/3. If I take the derivative of that, that's 3x squared. 1/3 times 3, they cancel each other out. Cool? Alright, let's do another one. Let's look at example number 2. Let's look at the function f of x is equal to x cubed minus 3x plus 4. And I want to find its antiderivative. If I'm finding the antiderivative, what operation am I doing? I'm integrating. So I'm going to integrate. I'm going to integrate the function I'm looking at, x cubed minus 3x plus 4. Don't forget your dx. Now, yes, I'm going to do it term by term. Because in our integral rules, did I have an integral rule for multiplying? No. Did I have an integral rule for division? But did I have an integral rule for addition and subtraction? Yeah, and it just said, great, it's the integral of each thing added and subtracted by each other. So let me go term by term. Integral of x cubed. Well, that's going to get me x to the 4th divided by 4. Minus 3. I'm going to increase the power on this. Remember, the power is 1 right there. So this is going to be x squared all over 2 plus 4. Think about it. What, when I took the derivative of it, just gave a singular number? 4x. So it's going to be 4x. Another way of thinking about that, if there's no variable there, what exponential power causes it to go away? A 0. Anything to the 0 power is 1. So it's really x to the 0th power. I increase the 0 power. I go to the first power. I'm just left with an x.
Yes.
Cool? Let's do one last one.
What about the bottom?
Say it again?
Bottom is just 1.
Yeah. I mean, I don't have to put the bottom if I'm divided by 1. Last one. And we'll get into some negatives and some fractions. Okay.
Yes, cheetah facts.
Dad, you said you it's not.
Cheetah facts. Have I told you about females?
No.
Females typically run the roost in cheetah prides, meaning that cheetah females will do most of the hunting, while dads stay with the youngs. with the young, and the females will typically stay with the young for 1 or 2 years, and then they'll leave them with the dads and go off hunting for the rest. Here we go. Square root x. Plus 4x squared plus 1 over x squared. There's my function. Now again, the only thing you know how to do is a variable raised to an exponential power. You have no idea what to do with square root. You have no idea what to do with a variable on the bottom. What I need to do, just like with my derivatives, I need to rearrange it so that it's a variable, exponent, all in one line. So, if I'm integrating this, how could I rewrite this so it has a variable and exponent? X to the 1/2. I appreciate your filter there, Jacob. I said I appreciate your filter there. If I wanted to rewrite this, this would be x to the -2. And again, don't forget your dx. Once you have it in that form, your life is very easy. You just go term by term and integrate it. X to the 1/2. Again, we are increasing it by 1. If I add 1 to 1/2, what do I get? 3 over 2.
Interruption. Teachers, just letting you know that the eco-fair is dismissing at this moment. In the next few minutes, you will be receiving all students from the eco-fair. So again, right now, it's about 9:36. If you'd give them a few minutes to get to your class, we are releasing from the comments. Thank you.
So, again, I divide by whatever number I added 1 to. So I know this is going to look gross, but what am I dividing by? 3 over 2. For now, I'm just going to leave it like that. I want to separate in your head the step where you're integrating, and then we'll go through and we'll simplify it, so you don't try and start combining those things in your head. Plus 4x, I'm going to increase the power, so it's going to be what? Cubed divided by 3. This one plus x to the what? Good. Remember, it's a negative number, so when you go up, you're going to add something, it's actually going to go up. It's not going to go bigger. Or, sorry, more negative. Divided by -1.
Wait, so it's always going to be, the exponent's always going to go to the bottom?
Yes, that's what my rule says. Integrating, it's going to add, and then divide by that added exponent. Now, from here, I can simplify this, and I would actually like to. If I'm dividing by 3 over 2, what is that? So this is 2/3 x to the 3/2. In these cases, let's just leave them as exponents. I don't care if you rewrite them as the square roots and all that jazz. Let's just leave it as exponents. Plus 4/3 x cubed. This one I am going to rewrite. X to the -1 is what? 1 over x. So minus 1 over x.
Do you write like f of x is equal to, or what do you write?
In that case, because I'm starting with f, don't worry about naming it as a function.
So just leave it.
Yeah, just leave it like that. That's fine. Talking about that. Now, there's an interesting case that we have not talked about. Every single answer, and I've not boxed them on purpose, is wrong right now. We have not included something yet. If I am, and I have a picture for this, so let me show you.
Square.
Look at this. Here is a bunch of family of functions. Hey, shh, please. Let's look at this one, and ignore the graphs for right now. If I took the derivative of x cubed divided by 3, what would be the derivative of that? X squared. The 3 is going to come down, and they will cancel. If I took the derivative of 3, what is that? See, so the total derivative of this is x squared. Let's look at this one. If I took the derivative of x cubed over 3, what do I get?
X squared.
If I took the derivative of 2, what do I get?
0.
So when I take the derivative of both of these functions, even though they are totally different, I get the same thing because of this thing out here, the constant. Because the derivative of any constant is what? 0. So, in order to account for that, I have to include something that says, wait, there could be a constant there. I have no idea what it is. Maybe I had a plus 5 on this equation. Maybe I had a minus 10 on this equation. I have no idea because when I take the derivative of plus 5 or minus 10, what does it go to? It goes to 0. The way I notate that is I put a plus C at the end of it. I'm always going to put on my indefinite integrals plus C's so that I can actually say, great, there might have been a constant in there. I just don't know what's going on.
Did you put that at the reverse power rule equations?
Yes, so your reverse power rule needs to have a plus C at the end of it because, again, I have no idea what's going on with a constant through there. And actually, there's one little caveat that we will come back to in a little bit that we need to include on this power rule. There's one power that doesn't make sense for this. There's something that we're going to try and do, and our little input-output machine is not going to like it, and it's going to sort of implode on itself.
Is there a way to find C?
There is. All right, let's look at an example. I'm telling you that f prime of x is equal to 6x squared. I'm also telling you that f of 1 is equal to negative 3. I want to find, bless you, I want to find the particular solution for f of x. So, a particular solution means, girls that are coming in. A particular solution means that I don't want this plus c. This plus c is the general solution. It's saying, okay, I have this generic case. It could have been a plus 5, minus 10, whatever. This is a generic or general solution. I want the exact equation for this. Well, first off, I have f prime. I'm going to f. What operation do I do? Integrate. Let's just start there. I'm going to integrate 6x squared dx. Alright, integral of 6x squared. Again, I increase the power, so it's going to be x to the what? Third. So this is equal to 6x third divided by what? 3 plus c at the end. Again, this is the general case. But I was also given another piece of information. I was given a singular point on the original graph. So what do you think I could do with that point? Yeah, let's plug it in. Because if I have the x and the y, I can figure out what this other unknown is, what this c is. So I can say that the y value, negative 3, is equal to 6 over 3. That's going to combine to give me what? 2. So 2x is 1 plus c. Right, this point acts as an anchor on my graph. Where these graphs were all over the place, it could have gone up, could have gone down, whatever. If I say, great, I am at 1, negative 3, it has to be a very specific point. I can't make all of these graphs go through that point. So that one point is saying, great, here it is. Here's the exact equation that you're going to be dealing with. 1 cubed is 1 times 2 is 2. Move that 2 over. That's going to be negative 2. Negative 3 minus 2 is going to give me. So, my particular solution for f of x is going to be 2x cubed minus 5. Everyone with it? All right. All right, let's do another example. And get ready, I'm about to rock your world. This is why today is the important. All right, I want us to find f of x. And here are the clues that I have been given. The clues that I have are f double prime of x is equal to cosine of x. F prime of 0 is equal, f double prime. Make sure you note that that's double prime. I don't remember if I said that or not. And f of 0 is equal to negative 2. Those are the bits and pieces I was given.
Okay.
Alright, let's start off with just the basics. How you would actually look at this problem and how your brain needs to function when tackling a problem like this. I'm given the second derivative. I'm trying to find the actual function. In my brain, as I'm traveling through there, what operation gets me from a derivative or a second derivative to the function? The integral. Okay, great. I need to integrate this somehow. But in this case, how many times do you think I'm going to need to integrate? Twice, because I'm given the second derivative. That's the first hurdle we need to jump over. So, I have cosine of x. I need to get to there, to the function, so I'm going to integrate. I do not go away. Spoon. He was one of my algebra kids from like 2 years ago. Integral of cosine of x dx. That doesn't look like a polynomial, does it? No. In fact, it doesn't look like we can apply the reverse power rule at all to this.
It's just cosine squared.
No, it is not. Think about it. The integral is an important. The integral is the antiderivative. It's saying, what did I take the derivative of that got me this? Well, what when I take the derivative of it gives cosine? Sine. Everyone grab your yellow sheets for a second. Look at the right-hand side of the front, please. First off, do you see anywhere where we have any identities for integrals on here? No, we don't. Because if I'm working forward, if I'm doing an integral, I'm working backwards. So these relationships work backwards. What is the integral of cosine? Sine. What is the integral of negative sine? What's the integral of secant squared? Right, so they work backwards just the same. Now what you are going to have to look out for is most of the time I will not have integral of negative sine. I won't have integral of, let's look at this one. This is the big case that clicked with some other people. If I am integrating just a to the x, what do you think the integral of a to the x will be? Yes, right? Because I'm working backwards. If I multiplied taking the derivative, working backwards, what do I need to do with this constant that's right there? I need to divide. So the integral of an exponential function will be the exponential function divided by natural log of a. It's just working in reverse.
So these are identities.
Yes, these are identities. Say this one. If I had the integral of positive cosecant squared, what would the integral of a positive cosecant squared be? Negative cotangent, because I'm just dividing by that negative one on the opposite side. The ones that don't have positive negatives, great, your life is awesome. Your life is totally cool. The integral of secant x tangent x, that's just going to be secant. That one works fine. Notice, however, integral of tangent. Do you know that? Do you see that on there? No. I don't have something over here that when I took the derivative of it, I just got a tangent. So I don't know the integral of all my trig functions. All I know is the integral of cosine, sine, secant squared, cosecant squared, secant tangent, and cosecant cotangent.
Oh, you just multiply times its...
Right. Those are the only ones I can do. So I can't do, say, like the integral of cotangent right now. I don't know how to do that. I can't do the integral of cosecant. I can't do the integral of secant. Because I didn't have something that when I took the derivative of it, just got me that specific function right there. Does that sort of make sense? I need to have that relationship in there that tells me exactly what it is. Now, eventually, we'll figure out how to deal with those things. We're going to have to do something called use substitution, but we'll get there in a little bit. Yes, ma'am?
So is the integral of positive sign negative cosine?
Yes, the integral of a positive sign would be a negative cosine. You still have to have that negative in there. It just flips to the opposite side. Cool? No, I mean, if you want to, that's fine, but I'm not going to. Eventually, when we get back from Christmas break, these integrals will then be fair game. When we get back from Christmas break, and maybe next week, I'm not sure, these integrals will be fair game. So, let's go back to the one we were talking about. Integral of cosine. We just figured out that the integral of cosine is what? Sine. Now, I promise you this will give you woes and lots of grief, so you might as well just kill it now.
Whoa.
Anytime you integrate a function, it always has to have a what? Plus c. Many of you will go very quickly through the test, and you'll see a lot of little minus ones on your test because you're just going, and for some reason you forgot to add your plus c. Anytime you're doing this integral, an indefinite integral, to find its antiderivative, you always need that plus c in there. Great. This was, we integrated once, so what function am I now staring at? F prime. Now, I'm going to stop here and use the bit of information that I had for f prime. So I'm going to plug in that, so it's going to be sine of 0 plus c is equal to 3, because that was the point I was given. Sine of 0, that's the arm going out. The y value there is what? 0. 0 plus c is just going to be c. So c is equal to 3. Oh, I'm not done yet. I still have to go on traveling through my function. I now want to find f, so I'm going to integrate my new function I just found with that plus c. So this is sine of x plus 3 dx. Now this is where that negative that Kat was talking about earlier comes in. The integral of sine. I have a derivative that tells me derivative cosine is negative sine. If I just have a sine and I try and integrate it, I still have to account for that negative, so it goes with my function. What's the integral of sine? Negative cosine. It's negative cosine of x. What's the integral of 3? 3x. And then at the end I always have to have a what?
Plus c.
Plus c.
I thought you said plus c. Like plus c versus plus c. That's what I heard.
So it's equal to f of x. So I'm going to plug in my values. Negative cosine of 0 plus 3 times 0 plus c is equal to negative 2. Cosine of 0 is what?
Negative 1.
Yeah, with the negative up there, it's going to be negative 1. Negative 1, that's 0, so plus c is equal to 2. And so I can add, or sorry, negative 2. Right, yeah. And so I can add that 1, so c is going to be equal to what? Negative 1. So, my equation for f of x. F of x is equal to? Nope. Negative cosine of x plus 3x minus 1. That is the full-blown equation for f of x.
That's crazy.
That is crazy. So we don't have to add a plus c to that, right?
Correct, because we found what the constants were exactly. We did add a plus c, we just figured out what they were as we were going through the problem.
So the whole point is to just find c.
Hmm?
Is the whole point just like you just have to find c?
Yeah, sort of. Now, the next step is a very important step because I'm going to link all the things that we've been talking about for the past 3 or 4 days. Okay, here's the train of logic. There was a crumb that fell on here. I flicked it out of the way, and I was reminded of something that happened in my room last night. It actually happened 2 weeks ago. Yesterday I was in my room. I saw a lizard in my room. It had crawled into my house somehow. And I tried catching it, and it ran underneath the bed. And I was like, well, I've accepted this fate now. So there was a lizard in my house for like the past 2 weeks. It's like been in my room. I saw him a week ago. I tried catching him. I got him, but they jumped out of my hands and into the laundry hamper and like crawled into the bottom. I was like, wow, this guy's really working it. He's earned his right to stay here. Yesterday morning, he climbed out from underneath my bed and climbed underneath this sock. I was like, I literally said, I was like, got you now! And like, got him. And I was like, haha, I've won. I've triumphed. And I took him outside. Why that crumb, me shaking it off, reminded me of that. But I have been living with a lizard for the past 2 weeks, but not anymore. I put him back outside. Thank you for coming to my TED Talk. What? I did not name him. But also, my girlfriend was here over Thanksgiving, and I failed to tell her that there was a lizard in our room until she left. And I was like, hey, by the way, and I told her this entire story. She's like, I hate you. And I was like, as well you should. This is valid. All right. Here's me linking all of the stuff together. Yesterday, we talked about this thing, the first fundamental theorem. First fundamental theorem of calculus. The first fundamental theorem of calculus said the integral from a to b of f prime is going to be equal to f of b minus f of a. And yesterday, we were using this to find different function values. You know how I gave you the integral, the area, and I told you a point, and I said, yeah, let's find one of the points, things like that. There's a relationship between all of this. This is a definite integral. In your brain, it's finding the area underneath the curve, yes? This is an indefinite integral. It is finding a function that we are calling the antiderivative. Those are all related. This is saying that the area underneath a derivative or the area underneath a curve is equal to the antiderivative at the endpoint minus the antiderivative at the beginning point. Which, nerdily speaking, that's crazy. That's super crazy that someone came up with this idea, I want to find the area underneath the curve. Well, let me find its related function by taking an integral, subtract the two bounds, and that is true. That the area underneath this curve that I'm dealing with, if I create a totally different curve that's related to it, and I subtract these endpoints, it's going to give me that area. The fact that someone figured that out and said this is true, that's nuts. It's super crazy. That's why it's called the first fundamental theorem of calculus, because it is so groundbreaking. When I think it was maybe Leibniz, I forgot who actually came up with it, that he said this or she said this. I think it was probably a he, because let's be honest, we're talking in olden days. That this came up and this was a thing. That was not meant as a hit. It was more of like a why weren't women doing things back then, or sorry, why weren't women allowed to do things? They should have been. I'm talking myself into a corner now. I'm going to stop talking. So, let me put that in words. The area under a curve, that area underneath the curve is going to be equal to the antiderivative of whatever that function is at the end minus the antiderivative at the beginning. Does beginning have two ends?
Yes. We got that one.
That's what the fundamental theorem is saying. So let me prove to you its listfulness. The integral from 1 to 3 of x squared plus 3 dx. One more go round. What is this asking you in your brain? Area underneath this curve from 1 to 3. Yeah? Now, yesterday, we had no idea how to do this. What was our solution to doing this?
Putting in the calculator.
Right, put in the calculator. We had a trick, and we had no idea what the calculator was doing. We are now going to learn what the calculator was doing. Calculator was doing this pretty complex equation. It's actually doing a Taylor series approximation, which we will learn way at the end, way beyond the scope of what we're doing right now. So, I need to integrate this. The first fundamental theorem says, great, if I want to find areas underneath curves, I just have to find the antiderivative and then plug in the beginning and the end. What is the integral of x squared? X to the third divided by 3. Integral of 3x. Now, I'm going to include this bar at the end. This bar says, great, I have integrated, but I have still yet to evaluate and plug in 1 and 3. It's just a notation saying, great, I've integrated, I've done the integration step, but I have not plugged anything in. Yes, ma'am? Cool? So, the fundamental theorem says it's going to be f of b minus f of a. So this is going to be 3 cubed over 3 plus 3 times 3. All of that minus the same thing, the antiderivative at 1. So 1 cubed over 3 plus 3 times 1. Now, if this was a normal free response, great. Safe stop, go on. I want to simplify it after Aiden's question.
So we don't have to put plus c?
Right, because this is a definite integral. This is saying, here's a point, here's a point. The plus c is already sort of built in there. I'm saying, great, these points that I was giving you up here, I'm not worrying about it. I have a starting point, I have an ending point. I'm just looking at that area down there. Cool? The only reason I needed a point over here is so I could see exactly where the curve was that I was looking at. Cool? Say it again? Yes, indefinite always needs a plus c. Definite, you do not need a plus c. Let's simplify. Let's do some mental math. 3 cubed, what's 3 times 3 times 3? Divided by 3, so a pair of those 3's are going to cancel. 3 times 3 is 9. 3 times 3, another 9. 1/3, so minus 1/3. 3 times 1 plus 3. Or, sorry, minus 3. Got to make sure I distribute this negative here and there. Alright, 9 plus 9, 18, minus 3, that gives me a 15. 15 minus 1/3. Well, I need 15 in terms of thirds. I believe that's going to be 45. But I subtracted the 3. 15 in terms of thirds is 45 over 3. So 45 over 3 minus 1 over 3 is going to be equal to 44 over 3. Now, we have a way to check this, don't we?
Yeah.
Let's go to the calculator, see if that's actually true. My calculator, remember I go to math where? Math 9. Integrating from 1 to 3. X squared plus 3 dx. 14.666667. Let me turn it into a fraction. 44 over 3. Now, one quick point. This is interesting, again, to me. What type of function is this? It is a quadratic. Specifically, it's a quadratic function shifted up 3. This is giving me the ability to find an unnatural area by hand. There is no way that you can split that up into really nice shapes to find it. You can maybe use this arc to find a portion of a circle over there, but that's going to be a really interesting and hard problem to do. So this is why this is so important. It allows me to find the area underneath oblong shapes. Things that are not normal shapes. Things that isn't a square, a rectangle, a triangle, a semicircle, something like that. This is now giving me all of the tools that I could ever want in my life to find areas and to find antiderivatives. And this is the relationship between the two. Dig? Alright. I have a couple I want you to try in our waning moments. Yes, Melanie, what's up? I know, I'm saying that this is this. I'm just converting it because to subtract fractions, I need the same denominator. I'm saying 15 is the same thing as 45 over 3. Alright, here's the two I want you to do on your own. First one, integral of 2x minus 1 times 3x plus 4 dx. Second one I want you to try, integral of x squared minus 2x plus 7 all divided by square root x dx. Don't get confused. Sorry, I should have written this better. This is the entire integral of this. It's not like the integral of the top and then all of that divided by square root x. And let me give you this hint. Do I have a rule for integrals of multiplying or dividing? No. So I need to get it so it's not looking like a multiplication problem or a division problem. I want to simplify it. And I think there are ways that you can simplify that. So try it, see what you can come up with.